Good afternoon, ma'am. I am Rika Joy A. Galipuso from BS Forestry, major in agroforestry. So I will be the reporter on Chapter 10 about forest dynamics. What is forest dynamics? Forests are dynamic systems that constantly change through natural succession and disturbance. Their structure provides vital ecological, economic, and social value, supporting wildlife and human needs alike. Management actions such as harvesting, fire and fuel control can alter forest development, making an understanding of forest dynamics essential. By studying succession and disturbance, resource managers can better plan for sustainability, habitat conservation, and disasters response while anticipating how forests may evolve over time. So, forests are always changing. They grow through natural processes like succession and can be disturbed by events such as storms or fires. These changes affect the forest structure, which is important for wildlife, people, and the environment. Human activities like cutting trees, using fire, or managing fuels can also change how forests develop. Because of this, it's important to study forest dynamics or how forests change over time. By understanding succession and disturbance, managers can make better plans to keep forests healthy, protect animals, prepare for disasters, and ensure forests continue to provide benefit for the future. So, this chapter will help readers understand how forests grow, change, and respond to both natural events like fire or storms and human actions like harvesting or planting. By the end of this, readers should be able to know what a forest community is, explain how trees compete and share resources, understand the idea of forest niches and gradients, identify the stages of forest growth or succession, describe how forest recovers after natural disturbance, learn about gaps in forest and how shade tolerance affect tree growth. It also shows how plant management and unexpected events can change forest structure, with examples like chestnut blight, Dutch elm disease, and sudden oak death. Finally, it introduced agroforestry system where trees and crop grows together and explain how their interaction can affect both farming and forest health. Forest communities. A forest community is a group of plants living together in one area, sharing resources like sunlight, water, and soil. These plants can prevent other species from entering the space. So, think of a forest community like a neighborhood of plants. In this neighborhood, trees, shrubs, grasses, and mosses all live together, sharing the same sunlight, water, and soil. Because they use up these resources, they sometimes prevent other plants from moving in. We can describe a forest community in two main ways. A, a physiognomy, the outward look of the forest, or the how the forest appears from the outside. Vertical structure, layers such as trees, shrubs, herbs, and mosses. Communities can also be described by the tree density and type of niches. So, tall trees at the all top, shrubs in the middle, herbs and grasses closer to the ground, and mosses covering the soil. But these communities don't stay stained forever. They change when these are the factors that affect the communities. Natural events like storms, fire, and diseases, and human activities harvesting land use, changes in nutrients, water, light, and soil. Because forests can look very different depending on plants and conditions, it's hard to give one strict definition of a forest community. Instead, we usually describe them in general terms. For example, scrub oak forest from North Carolina. This type of forest has scattered long-leaf pine trees, ground mostly covered with wiregrass and other plants like silkgrass, blue stem grasses, and dwarf huckleberry shrubs. It shows how different plants from layers and share space in one community. Interaction, competition, and strategy among tree species. Tree interaction and competition. Trees compete with each other for sunlight, water, and nutrients. This success depends on the size and health of their canopy, or leaves or branches, and root system. Resource reuse. Trees divide their energy, like carbon, into shoots, stem, roots, and reproduction, like flowers and fruits. To survive, they must take enough water and nutrients to keep growing. Above ground competition or the light. Bigger trees shade smaller ones, making it harder for them to get sunlight. This is called size asymmetric competition or unequal shade. Intolerant trees struggle if they are stuck in lower canopy layers. So, below ground competition or water and nutrients. Root size determines how well a tree can compete underground. This is called a symmetrical competition or more equal. Some species have deeper roots, giving them an advantage. In forests, trees are like neighbors fighting for limited supplies. Big trees with wide canopies block sunlight from smaller ones, while strong root system helps certain trees absorb more water and nutrients underground. This constant competition decides which trees thrive and which ones weaken or die. So these are the effects of competition. Weak trees become more vulnerable to disease or death. Competition can directly cause tree mortality at any stage of life. Tree rings show signs of competition. Tight rings means limited resources. Canopy positions matter. Dominant and codominant trees at the top get more light. Intermediate and suppressed trees often struggle, especially if they cannot tolerate shade. Some trees can handle shade and survive in lower layers, but others, like shade intolerant species, need direct sunlight. If they don't get it, they struggle. Over time, competition shapes the forest structure, deciding which species dominate and which ones fade. Even tree rings can tell the story of its struggle, showing years when resources were scarce. Gradients and niches. Environmental gradients. Forest growth depends on site conditions like elevation, slope, soil type, moisture, sunlight, and land use history. Certain species prefer specific conditions, like white oak grows best on dry, south-facing slope. Tree sensitivity to gradients changes with age, like sampling are often more affected than seedlings or mature trees. In some regions, gradients are well studied in India and Europe, while in others they remain less understood, like Finland. Environmental gradients are variations on site conditions, such as elevation, slope, soil type, moisture, sunlight, and land use history that shapes how forest grows. Different species thrive in specific environments. For instance, white oak grows best on dry, south-facing slope. Tree sensitivity to these gradients also changes with age. Samplings are often more vulnerable than seedlings or mature trees because they are still establishing roots and competing for light. While regions like India and Europe have been widely studied for how gradients affected forest compositions, areas such as Finland remain less understood. Recognizing these patterns is important for guiding reforestation, conservation, and sustainable forest management. Niche, or the tree role in the forest. A niche is the role or place of a tree in a forest, defined by resources it needs to survive, such as light, water, nutrients, and space. There are two types of niches. The fundamental niche, which the full range of conditions a species could live in without competition, and then the realized niche, which is the actual space it occupies when competition and environmental limits are considered. Niches can be broad, covering many conditions, or narrow, restricted to specific ones. They may also change or shrink during the tree lifespan as its tolerance to environmental factors shifts. For example, examples of niches. Different species show unique niches preference. sisal oak can germinate in many different conditions, while European beech has narrower range. Norway spruce often regenerates on fallen logs or stumps, showing how even small space can serve as niches. Italian maple seedlings establish best in microhabitats with shrubs and leaf litter rather than bare soil. These examples highlight how niches can range from large landscape to tiny microhabitats and how species adapt to spaces available to them. Niche overlap and construction. Sometimes species share parts of their niches, which allow them to coexist in the same forest. Soil nutrients and shade tolerance often influence how well species can use their niches. In some cases, plants and animals can actively change their environment to create better conditions for themselves. A process called niche construction, a well-known example is the beaver, which build dams that reshapes the water flow, soil nutrients, and habitats affecting many other species in the ecosystem. Forest succession is a natural process where one group of plants gradually replaces another, changing the overall composition and structure of a forest over time. This sequence of changes is called sear, and each step in the sequence is known as searal stage. Succession can be driven internally by the vegetation itself or the autogenic, such as trees growing larger and altering condition, or externally by outside forces or allogenic, like storm, fires, or human activities. The pace and direction of succession depends on several factors including soil quality, seed availability, competition among plants, weather, and random events. The primary succession begins in area where no soils exist, such as bare rock, volcanic deposits, or landslides. In these places, pioneer species are the first to colonize, slowly creating soil and condition that allows other plants to grow. This process is independent of continuous human management and represent the very beginning of forest development. The secondary succession, on the other hand, occurs in areas where soil is already present but vegetation has been removed or destroyed. It is triggered by disturbance such as wildfires, hurricanes, logging, or abandoned farmland. This type of succession is common in regions where agricultural lands reverts back to forests, such as in parts of the southern United States and western Europe. For example, in the Mississippi floodplains, succession begins in the fast-growing pioneer species like cottonwood and willow. These trees quickly establish after disturbance and prepare the site for later species such as elm, hickory, maple, and oak. On the Hawaiian volcanic deposits, the pioneer tree or the Ohia lihoha determines early stage, regenerating itself despite being shade intolerant, showing how pioneers are vital in starting succession. Successional process. Succession usually starts after a disturbance, when new growth emerges from seeds, roots, sprouts, or stumps. This is the called initiation stage, where most seedlings establish in a short period. Forests here often look even age, but over time, competition and regeneration create uneven age system with multiple age groups. The stand initiation stage sets the foundation of a forest recovery. Seedlings and saplings established quickly after events like fire or logging, often in bursts rather than continuously. Success depends on seed viability, soil quality, often logs and as nurse logs, climate, and disparate agents like wind or animals. For example, pine trees in Arkansas stays in the stage for about 12 years, reaching crown closure by year 17. The stem exclusion stage follows once space is filled, resources become limited. Intense competition causes shade intolerance, plan to disappear, while vertical layering develops as taller trees suppress those below. Soft thinning occurs, and pioneer species are often replaced by shade tolerant species, marking the shift toward a more structured forest. The understory reinitiation stage comes later. Once the canopy matures, shrubs and younger trees return to the understory, using gaps created by dying overstory trees. This increases diversity and biomass, serving as transition between dense competition and older forest characteristic competition and older forest characteristics. The climax stage represents the mature forest and ecological balance. It is marked by large trees, fallen woody debris, and high biodiversity. True climax forests are rare due to disturbance, and therefore varies by region. For example, subtropical evergreen rainforests in southern China or northern hardwood forests in Michigan achieve this stage naturally can take centuries, making it more an idealized endpoint than common reality. Old growth forests are ecosystems that resemble climax forests that are sustained through natural cycles of thinning, gap formation, and regeneration. They are recognized by this complex structure, which includes tall mature trees, fallen woody debris, and dead standing trees, and seedling growing beneath older trees. These forests are in even age, highly diverse, and vary by region. For example, in North America, they often contain trees over 150 years old, while in the British Columbia, the threshold is around 140 years. Distinct traits such as unusual bark, dense understory plants like ferns, or multiple age classes separated by centuries also mark old growth condition. Late successional forests are older than economically mature forests but not as structurally diverse as old growth, typically at least 100 years old in temperate and boreal regions. They represent a transitional stage between managed forests and true old growth. While they can develop natural over decades, forest managers can may accelerate their growth through practices like selective harvesting, reintroducing species, or restoring competition to speed up ecological processes. Forest succession is shaped by both natural and human events. In northern Minnesota, forests that regenerate after harvesting were the first dominated by aspen, but later mixed with shade-tolerant species like balsam fir, red maple, and white spruce. Disturbance such as insect outbreaks, storms, and canopy gaps often space for new tree cohorts, creating multi-species, multi-age forests. This ongoing cycle builds complexity, resilience, and biodiversity, showing how forests continually adapt to changes. Thank you. That's all my part, and to be continued by Freya Quinones.